This is a maximum minimum sum where you have to use calculus, differential calculus, to find the maximum value or minimum value. But it has a geometry, area, volume question in front of it before the actual calculus sum. A solid rectangular block has width x centimeter. So if you have a box like this, rectangular box, so something like this, so it has, this is the width, so suppose this is x, and this is the length 4x, and this is the height, and the height is not in terms of x, it's h. So question number A says that, and we have also another information, the total surface area is 720 centimeters square. That means every single surface. So altogether there are six surfaces. There are six surfaces. So we have to find an expression like this. So let's use the surface area concept. So the surface area is 720 centimeters square. Now how many surfaces do we have? We have this at the top. So let me use a different color. At the top we have this, and this is also at the bottom. So we have two different rectangles over here. So the first one would be length into breadth, 4x into x. Since the bottom one is also the same, we write 2 into that instead of adding. Then we have this side over here, and this would be this side over here. Uh, so this would be again length into breadth, which is h into x. So h into x, and since there are two over here, one over here, this would be 2 into that, plus now the other two shape, they're going to be this one and the one on the other side. So this would be 2 into x, we have h, and we have 4x, and this is altogether equals to 720. So let's get going. So 2 4s are 8 x squared plus 2xh plus 4 2s are 8 xh. It's a good idea to write in alphabetical order, but since they wrote xh, I'm also writing xh equals to 720. So what we can do over here is 8x squared plus, we can add 8 plus 2, 10xh equals to 720, and we can divide by 2. So that turns out to be, therefore, 8 divided by 2 is 4x squared plus 10 divided by 2 is 5xh equals to 720 divided by 2 is 360, and we have proved the expression. Even if you hadn't, you can take this answer and do the next one. It doesn't really matter even if you cannot do the first one. So question number B, volume. So expression for volume. So we know volume of a any type of box, cuboid, is length into breadth into height. So the expression for volume would be, the length is 4x, the breadth is x, and the height is h. So it turns out to be 4x squared h, but here there is no h. So we have to rearrange this and find an expression for h. So what we can do here is, let me write it out here. You can write, we know 4x squared plus 5xh equals to 360. So we know 5xh is 360 minus 4x squared. Therefore, x equals to 360 minus 4x squared divided by 5x. So we can get that expression. So we can write equals to, so right, let me write it over here. So volume equals to 4x squared 360 minus 4x squared divided by 5x. If we simplify, this x and this x cancels over here, we can write 4 by 5, and we can take the x outside the bracket, and we can write 360 minus 4x squared. So this is the expression. This is also done. Now question number C. Question number C, we have to find the value of x for which dv by dx equals to 0. This is the rule. At the turning point, the derivative is 0. So let's write down v simpler terms. So 4 by 5x into 360 is going to be, let me see this. So 4 into 360 divided by 5, and that is going to be 288x, minus we have 4 4 is 16 by 5 x cubed. Therefore, let's do the derivative. dv by dx is going to be 288 minus, this is going to be 16 by 5 is the constant, and derivative of x cubed is 3x squared. So now what happens when at the turning point gradient is 0? So we can write at dv by dx equals to 0, 288 minus 16 3s are 48, 48 by 5 x squared equals to 0. That means 288 equals to 48 by 5 x squared. That means 288 into 5 divided by 48 equals to x squared. That turns out to be, so 288 into 5 divided by 48. That is 30. So therefore, x squared equals to 30. X equals to plus minus square root of 30, which is plus minus square root of 30 is going to be plus minus to 3 significant figure 5.48. 5.48. Now they ask for the value of x. Now since this is a some sort of a practical question where we have a box, since x cannot be negative, in that aspect we can just write the value of x to be positive, 5.48. That's good enough over here. This is question number D. So second derivative. So we know that dv by dx is equals to 288 minus 48 by 5x squared. So the second derivative is going to be, so therefore d2v by dx squared equals to, if you differentiate 288 it becomes 0. So minus 48 by 5, and the derivative of x squared is twice x. Obviously this is going to be negative. So at x equals to, we have the value of x as 5.48, d2v by dx squared is going to be minus 48 by 5 into 2 into 5.48, which is going to be negative because we have a negative in front of here. So we don't have to calculate this. We just need to know whether it's positive or negative. So since d2v by dx squared is less than 0, it is maximum. So that's all they ask for, whether it's maximum or not. And the next question, find the maximum volume. So we have to put down the value of x in the expression of v and find the maximum volume. So let's do the final one. So question number E, at x equals to 5.48, v equals to, expression for v is right over here. So 288x minus 16 by 5, 5.48 cubed, and this turns out to be, so the calculation turns out to be 1051.6. so 1051.6. In the question, is there any significant figure? To the nearest centimeter cubed. So the nearest centimeter cubed would be 1052 cm cubed.